Good morning. Today I wanted to talk about scientific notation. Now, scientific notation is a way that we're actually able to talk about numbers. For instance, on the screen, you can see some numbers that are kind of familiar in our daily lives. 45, 30, a million, 9.67, 5,000, 0.033. You get the picture. All these numbers are reasonable and something we could see possibly every day. However, there are some times in chemistry and in life where we're going to be dealing with numbers that are extremely large or extremely small. Now, besides being a pain to write, I'm sure none of you want to copy this down a few times for a math problem or this one. Scientific notation is a way that we can express these numbers in a way that not only makes them quicker to write, but easier to understand. Because looking at this, I can't even fathom what this is. We can kind of go from there. So how do we do this? Well, with scientific notation, the first step is always to find the first two non-zero numbers, and that's where our new decimal point is going to be. This decimal point will serve and be the same just like it is here and just like it is here. Then, what is traditionally normally called the bucket way, you're just going to start to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Well, what this says is this is essentially 1.2 times 10 to the 25th power. This is moving in this direction. This is a large number, so we know that it's going to be positive. With this one, and if you don't mind, I'm going to switch the color to green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. However, because this number is small, you notice we went in the opposite direction. That is essentially the same as dividing. Now, there's an easy way to do this. We have 4.56. Again, I went in between the first two numbers. Not between the 5 and the 6, the first two, which is 4 and 5. We can still multiply, but this time, instead of having 10 be the positive 25, or in this case, positive 14, you can multiply it by 10 to the negative 14th power. That means that we can use the same process for both large numbers and super tiny numbers. And this is a very nice tool. For example, in chemistry, we use something called the mole. And I have to know that this is 6.022 times 10 to the 23rd. Again, I don't want to write this thing out. That'd be no fun at all. This and this are the same thing. Again, 6.022 times 10 to the 23rd. You can see, same thing. I started in between the first two numbers. Again, because of these twos, 6 and 0 are the first ones. You're always going to start after all this zero mess here. So you never want to start before that. So I'm never going to start over here. It's always going to be kind of where your actual numbers kind of exist. And there might be a zero there. Just to do two more examples. You can do this also with small numbers. For example, here and here. So in these cases, this would be 7.8 times 10. Again, we're going this way, so that's negative. 1, 2, and negative 3. And here, 1, 2, 3. This is 4.51 times 10 to the positive third. Hope you enjoyed this quick little demonstration on scientific notation, and have a great rest of your day.